With that, I'm going to talk about building efficient and reliable AI workflows. And again, originally, this is kind of around building computer vision pipelines, but all this really goes towards any other AI pipeline. So a lot of what I'm going to talk about is also used for like training LMs and other efficient pipeline methods or AI workflows. So a tiny bit about me. My name is Sage Elliott. I work at union.ai and flight.org, or Flight is our open source, so you can go check it out at flight.org or the GitHub, and I'll talk a little bit about them later, but it is a AI orchestration platform that makes it really easy to implement a lot of the reliable and efficiency things that you want to think about that I'm going to talk about here. I live in Seattle and I run an AI book club, which I usually have like over 100 people come to that. If you're interested, follow me on LinkedIn. We're currently reading reinforcement learning for finance, but we've been reading a lot of other Gen AI books as well. And previously, I've worked a lot in computer vision and ML monitoring, evaluation, MLOps in general, and then also a little bit of a previous background in hardware and IoT and robotics. So I still love tinkering with hardware as well. If you like that type of stuff, again, feel free to connect with me and ask me any questions about it. And that's usually what I talk about. So building AI pipelines or kind of MLOps, if you've trained a model before, you've probably had some form of this pipeline. It might have looked different. You might have had way more steps. It could have been implemented in a notebook. There's a whole bunch of different ways to do this, but MLOps is kind of the set of practices that aim to deploy, monitor, and maintain your machine learning models in production. And then I like to use the terms reliably and efficiently. And I usually come back to those terms quite a bit. And when I'm helping people implement their pipelines, I think about that. And I think a lot about cost, optimization, collaboration, and then also compliance, especially for some specific industries. So this is kind of your bare minimum pipeline, like I mentioned, that you're probably going to have some form of collecting data. You're going to probably also do some sort of data evaluation, like we saw with Voxel 51, potentially some pre-processing that data. Going to train a model, evaluate that model, ship the model. Shipping the model looks very different depending on your use case. It could be to an edge device, out literally in like a cornfield. I've worked a lot in like edge computer vision before, and so there's like interesting stuff you have to think about once the model's there. How do you monitor it? Because once the model is shipped out, you should be monitoring it in some form to make sure that it's still performing as you kind of expect. And from every single one of these steps, it's very common that you're going to rerun this pipeline over and over and over again. And doing this at scale with a lot of data or very large models can add a lot of cost and a lot of time. So you want to think about how can you make these reliable and efficient, like I said, and this is a big part of doing MLOps correctly or well inside of your org. And again, like I said, usually you have a lot more steps. Like you have the annotation phase, processing data. With Gen AI, you might have like vector databases and guardrails you want to implement in A/B testing. So fortunately, there are many great tools for these steps that make it way easier to kind of do all of them. We see Voxel 51 is mentioned here several times. We actually have customers that use Voxel 51 and Union together, so we already integrate really well with them for building like extensive computer vision applications. So kind of tying all these tools together, again, going back to reliable and efficient, you want to build those workflows that are the core of your AI pipelines and MLOps. And you want to think about usually scalability. How do you facilitate the scaling of AI workflows to handle very large data sets and complex models? Again, you see this a lot in computer vision, whether that's like self-driving cars or healthcare data sets. They're usually very, very large. Some healthcare, for example, you have really large images with metadata. So you need to be able to scale compute to handle that. You want reproducibility. How do you ensure that your workflows and data can be consistently reproduced between tasks and every time you rerun them, which also aids a lot in the collaboration and transparency as well, if you're working with a team. And then versioning. You've probably versioned your code before. You also usually want to version your data and your models. And every time you rerun a workflow, like I mentioned, you're probably rerunning this over and over quite a bit of times, whether that's from the evaluation state, the shipping, or the monitoring. Every time you run it, it's really useful to have a full version of that lineage. So when you train that model and that model's out in production or you're debugging it, you can actually see the exact data set that went into that or any other hyperparameters, not just the code that model was trained on. And this is useful for pretty much any team, but for some teams in particular, it's much more required. So if you're working in like healthcare or finance, there's actually a lot more of compliance stuff that you need to track lineage on so that you can debug and understand like why a model made a decision. You want to think about developer efficiency. How do you allow your AI engineers or ML engineers to focus on kind of the aspect of doing the development and training, and a little bit less about hopefully infrastructure management. And again, when I help people implement efficient pipelines, it's often to hear something like, oh, we were going from experimentation took weeks to days, or going to production took like months to quarters to weeks or a month. And then cost efficiency. Everyone loves this one in your company. So you want to optimize your resource usage, retry, so that if your pipeline fails, can it have good fault tolerance and actually retry from there without having to rerun all the other tasks. So this is actually really big in AI agents right now. So if you have an AI agent working on a long task and it fails somewhere, you don't want to rerun and spend all the tokens again to get back to the state that you were. You want to basically have like a cache input output of the state and then be able to recover gracefully. And then caching in general, if you're going to be rerunning that pipeline like we saw over and over again, you probably don't need to rerun every single task all the time, like downloading the data set, for example. And this can often see a lot of savings. Like it's not uncommon for people to go like 30 or over 50% of cost reduction when you implement a really well created MLOps pipeline inside your organization. And often that comes from maybe when they built that originally, they weren't thinking about doing everything at scale like they are now, and then you kind of redo it with all these kind of modern pieces. And just taking a little bit of a closer look at efficiency, these are some of the top things that when I talk to people like, oh wow, you went and now you're like 50%, you have a 50% cost reduction. What were those big factors that helped you? And these are some ones that I see come up quite often that people mention. So this one kind of sounds a little bit like a no-brainer, is optimizing for local and cloud development, but not every team or every tool is kind of set up to utilize your local compute resources when you're doing debugging or building your pipeline for the first time. And then you can kick off the full pipeline with extensive GPU resources in the production cloud. So you might want to even use like a test version of a model or a small version of a model and a subsample of the data set, build out your pipeline locally. Most of us have pretty powerful MacBooks that can actually do quite a bit. And then when you're going to be rerunning that pipeline a lot, or you need those extra GPUs, then kick off to the cloud production. And part of the time savings there is also, I don't know if anyone's worked with like clouds and containers before. We have to wait for the compute resource to spin up and then run the code. And then if it fails, you have to go get that failure message and then go back, do some edits, do that over again. So it just adds like minutes to your development time, which can add up quite a bit. Leverage caching in the pipeline. I kind of mentioned this before, but if you're running that training over and over again, and let's say here we are downloading a data set, pre-processing that data, and then training the model. But for this workflow, I really just want to change some hyperparameters in my model. I don't want to download the data set or pre-process the data set every time, but I want to rerun this whole workflow with that cache state. Implementing caching and having that in your pipeline, again, saves a lot of redundant cost and time for your development. And then, like I mentioned, kind of similar or somewhat related is the retry fault tolerance. So if you're actually running a kind of pipeline as a not training, but like having that in production, having retry fault tolerance is a big deal. And like I mentioned in AI agents, it's actually one of the biggest deals right now when I'm talking to people implementing that in production. Task level resource management and containerization. This is a huge one. So if you're implementing a pipeline, like kind of here's an example one, for every single one of these tasks, if you're downloading a data set and that data set's massive, like we had talked about, and it's going to take like an hour to download, you probably don't want to be using a GPU for that. So it's pretty common that for all these tasks, you're going to have some sort of resource attribution defined for them. So people often use Kubernetes for this right now, where you could spin up a container and compute resources for one of those single tasks and say how many CPUs, how much gigabytes of memory do you want, what container image do you want for that task. And so you can see for downloading data set, for example, we just want like CPUs and some gigabyte of memory. And then when we're training our model, that's when we want more resources or we want to have our GPU running. That way we're not like either hogging all the GPU time or paying for those expensive GPUs when we're not using them. And then once you have that implemented, it's pretty common that, like I've done this before, where I kind of over allocate resources and then it works and that's great. But if you can monitor that in production, then this also helps a lot too. So if you're declaring you need 4 GPUs, but actually you're really only using one, then again, that saves you a ton of money as well in your pipeline. And then mitigating errors, so type safety. This might seem really obvious for people depending on where you came from. If you've programmed in other languages that weren't just like JavaScript and Python, but adding type safety to your pipeline can really help reduce your debugging time as well, making sure that you're getting the output that you're expecting and input that you're expecting at your kind of build time. And then also this helps improve readability and collaboration across teams as well. And so there's so many little kind of opportunities inside MLOps where you can improve efficiency. And then kind of a joke, but also not really, is I put and promotion. So it's pretty common when I work with teams and people and they implement these like modern MLOps pipelines in their company. Well, if they're the one building that out from like kind of the first time building that modern MLOps pipeline, and then people see like how the cost efficiency and time efficiency that they've helped provide inside the company, it's not uncommon for them to get promotions. I can't guarantee it, but like I said, kind of a joke, but also not really. I see that quite a bit. I mean, who loves it when you save a ton of money? Usually that's like your boss or someone higher up in the company. So with Union or Flight, like I said, Flight is our open source. You can go check it out. I think Jimmy might have shared the link already in the chat, but go check out our GitHub. Um, it's pretty popular. It's used by thousands of companies in production right now. Actually, I can almost guarantee that most people here have probably interacted with a machine learning model that was trained on Flight at some point, whether from large social networks or if some self-driving cars that you might have been in use Flight behind the scenes to kind of orchestrate their MLOps and AI training. So we make it really easy. This is kind of what it looks like. Again, you could join the workshop or go check out that GitHub repo and dive actually into full code examples. But here's kind of what it looks like. You write a Python function kind of like you normally would, but we do enforce typing here as well. So we're saying this function is expecting a data frame here to be returned. And then we add this decorator on top of your Python function. And then you're just passing in parameters like, do you want caching? What cache version? What container image do you want? We actually even have a feature in Flight called image spec where you can define your containers directly in Python. So you don't even have to write Docker files. And then when this task runs, it'll say, does that image already exist? Yes or no. And then it can actually just build it remotely and then pull it down into this task. And then if it already exists, it just pulls it down automatically. And then here you request the exact resources that you want for your specific task here. So for downloading data, we don't need a GPU. We just say, this is the amount of CPUs we want. This is the amount of memory we want. And then also I'll mention 2.0 is coming really, really soon. We have some very exciting, did I already share that? I think I did without mentioning it. So we're doing an event launching 2.0. There's going to be some really exciting stuff there, especially if you're interested in like agentic AI. We have a lot of features coming out around there, still keeping kind of the things everyone loves in 1.0, but we're making it a lot more dynamic. So it's going to be really exciting. Again, as declarative infrastructure, versioning is built in. So every time you run a workflow that you build in Flight or Union, it's going to be automatically versioned, and you can go get that lineage of the data to model. It has type safety. It's flexible. There's a big plugin ecosystem, but also it's just running compute. So most stuff you don't even need a full plugin. If it runs in like Python, it should probably be able to run in your container here. Checkpointing for fault tolerance. It's scalable. It's built on top of Kubernetes. So when you define these resources in there and container images, it's really, really tied to Kubernetes and scales super, super well. So it's used by thousands of companies in production, like I mentioned already. Go check it out on GitHub. And then, like I mentioned, originally, this is kind of part of a workshop. So I'll just show real quick a larger sample of the code. Here, this is actually part of the computer vision workflow that we build in the workshop, where again, this is kind of the Flight part where you're defining the container image, the caching, cache version, those specific resources. Here's training a model. We're just declaring a GPU here. If you're just doing this, you can actually also declare the exact GPU accelerator. Or when you set up Flight, you can say what the default one is going to be, and that's how it pulls it in. And then you're just writing your kind of whole Python function here. And then you get a UI as well. All the stuff you can do through the UI, you can also do in the CLI or in the Python SDK. For example, this is the workflow that we build. It downloads a data set, downloads a model. We train the model. We verify the data annotations are correct in our data set, and then evaluate that model. You can click on these nodes. Inside here, you have the versioning of all the inputs, outputs, automatically, again, already versioned here. Every time you run the workflow, it's all versioned as well. You can embed visualizations directly in the deck. So if you come back and you want to look at the lineage and learn more about what was going on in this workflow, you can embed all that in a deck here too, which makes it really, really convenient to share with teams as well. So anyone could come in here and kind of debug what was going on. So this is the evaluation. You can see this is the predictions here, and then some other prediction metrics. So I could actually come back and even go to like this artifact tab, see that this is a fine-tuned model that came in, go click on lineage and actually see what generated it, go back to that full workflow, even if I didn't run this, and then I can go through and see what was going on here really easy across teams. So if you want to build an example, go ahead. Like I mentioned, you can go to the GitHub. And I'll also mention too, so Flight runs on Kubernetes, so you need a Kubernetes cluster to run it. If you don't feel like setting that up to try it out, we have a serverless version of Union that's kind of like a good playground for testing out either Flight or Union. And you don't have to set up your cluster. You can just sign up for free and you get $30 of cloud credits in there. So there's GPUs and stuff for you to mess around with as well. So I hope, again, this is kind of meant to originally be part of a workshop, but hopefully these interesting things like whether or not you use Flight or Union, some stuff maybe you didn't think about in a pipeline about how to make it more efficient, you could look at different ways to implement these in there too. But again, I've seen these repeatedly just make a really big difference when people take in these modern practices to their pipeline. So that's kind of all the talk I have. Thank you, Jimmy.